Welcome to all today's class about kinetic theory of gases presented by Dr. S Karthika Rani, Assistant Professor, Department of Physics, CPA College, Bodi. Three states of matter: solid, liquid, and gas. There are three gas laws: Boyle's law, Charles' law, and Gay-Luskas's law. Boyle's law states that at constant temperature, the volume of a given mass of a gas is inversely proportional to its pressure. PV is equal to constant. Charles' law states that at a constant pressure, volume of a given mass of gas is directly proportional to its absolute temperature. V by T is equal to constant. If the pressure, volume and temperature are same, then N is also same for all gases. Alternatively, PV is equal to N kBT. Kb is the Boltzmann constant, that's value is 1.3 into 10 power minus 23 joule per Kelvin. The law of Boyle's and Charles are strictly valid for real gases. Only if the pressure of the gas is not too high, the temperature of gas is not close to the liquefaction temperature of the gas. So we can write PV is equal to nRT. The behavior of gas molecules is dependent on the properties and laws obeyed by the molecules of the gas. Any gas consists of large number of extremely small particles is known as molecules. These molecules always in random motion. A gas is enclosed in a container is characterized by its pressure, volume and temperature, which are the macroscopic parameters. These parameters are not considered for individual particles. This is the difference between ideal and real gases. Ideal gas at all pressure and temperature obeys equation PV is equal to nRT. Real gas at low pressure and high temperature obeys equation PV is equal to nRT. Ideal gas at absolute zero temperature, volume of the molecule of an ideal gas is zero. At absolute zero temperature, the volume of molecule of a real gas is non-zero. Here, ideal gas, there is no intermolecular force between the molecule. There is intermolecular force between the molecule present. It has only kinetic energy. It has both kinetic energy and potential energy. There is no potential energy because intermolecular force is zero. Potential energy not equal to zero. At absolute zero temperature, the volume, pressure and internal energy become zero due to its absence of collision. All real gases liquefied before reaching absolute zero temperature, but internal energy of the liquefied gas is not zero. Assumption of kinetic energy of gases. A gas consists of a large number of tiny particles called molecules. The molecules are perfectly elastic sphere of very small diameter. All the molecules of same gas are identical in shape, size and mass. The molecules are always in state of random motion. Due to their elastic collision, they collide with each other and also wall of container with no loss of kinetic energy during collision. Actual volume occupied by a gas molecule is very small compared to total volume occupied by the gas. Between two successive collisions, molecules travel in straight line with a constant velocity called free path. The time taken for collision is very small as compared to the time required to cover free path between two successive collisions. Average kinetic energy of gas molecules is directly proportional to the absolute temperature of the gas. Free path. The distance traveled in straight line by the molecule between two successive collisions is called free path. Mean free path. The average distance covered by the molecule between two successive collisions is called mean free path. Mean velocity. The average value of the velocity of all the molecules of gas is called mean velocity. Mean square velocity. The average value of the square of velocities of all the molecule of gases is called mean square velocity. Root mean square velocity. The square root of the mean square velocity of the gas molecules of the gas is called root mean square velocity. Pressure of a gas. Consider an ideal gas. M. Total mass of gas. L. Length of each side. N. B. The total number of molecules of the gas. M is the mass of each molecule. V. L cube. Volume of the container. Rho is equal to capital M by V. Consider a fixed mass of a perfect gas enclosed in a cubical vessel. The gas molecules are constantly moving in all directions with all possible velocities. Initial momentum of the molecule is equal to mvx. Momentum after collision is equal to minus mvx. The average pressure is equal to average force per area of shaded wall. Finally, average pressure we can write 1 by 3 capital M by small v v square. This means the average energy per molecule is proportional to absolute temperature of the gas. Thank you.